So we're going to do two different initial value problem examples. And our first one is going to be y prime plus 3y equal to 13 sine 2t with y of 0 equal to 6. And the thing we're going to need to take care of this is to remember that we learned L of sine kt is k over s squared plus k squared. And then if we just jump into solving this equation, we're going to want to take Laplace of both sides. So that's like our step one. I'm usually going to take them on like separate lines and then set them equal later, just because sometimes taking Laplace can be like very long. So I'm going to take Laplace of the left side, and then we'll think about that sine function on the right. So in this case, by linearity, this is L of y prime plus 3 L of little y. And then I'm going to need to use that derivative property to deal with y prime. So it's a first derivative, so I take s to 1 power multiplied by capital Y, and then I subtract y with no derivatives, and I'm out of powers of s. And then for my next term, I've got plus 3, and then L of little y is capital Y, so I don't really have to do anything special there. I know eventually I'm going to have to solve for capital Y, so I'm going to rearrange this. There's s times y and 3 times y, so I'm just looping those together. And then I have minus y of 0. But for us, we'd like to get rid of any numbers as soon as possible, or sorry, get rid of any variables as soon as possible here. So we want to make sure to substitute in that my y of 0 is 6. Because I won't know how to take inverse Laplace of y of 0. I might like forget what's happening or accidentally turn it into like capital Y times 0. Now that I've done Laplace of the left side, I can go ahead and try Laplace of, oops, I'm still on step 1, Laplace of the right. So I'm going to take Laplace of 13 sine 2t. Again, I'm going to use linearity. That's 13 L of sine 2t. So for me, in this case, k is 2. So that's going to give me 13 2 over s squared plus 2 squared is 4. And then multiplying those numbers together again, because I'm going to end up solving for y, so I kind of want to start to simplify things a little bit. I'm going to have 26 over s squared plus 4. And now I'm ready for step 2, which is setting both sides equal. So those two things that I took Laplace of, they were equal to each other before, so after I take Laplace, they should still be equal. So I should have that on the left, s plus 3y minus 6 should be equal to, on the right, 26 over s squared plus 4. Once I have that, it's possible for me to do step 3, solve for y. I'm just going to go ahead and do a little arrow. So that means that s plus 3 times y is equal to 6 plus 26 over s squared plus 4. Or y is equal to 6 over s plus 3 plus 26 over s squared plus 4 times s plus 3. And then once I've isolated y, I want to take the inverse Laplace to get my answer. So when I take the inverse Laplace, I'm going to have L inverse of y on one side, and that's going to be equal to L inverse of 6 over s plus 3 plus 26 over s squared plus 4 times s plus 3. And this is where it starts to get a little bit complicated because I've never learned how to take inverse Laplace of something that looks like this. We're going to have to do partial fraction decomposition to deal with it. And that's going to take a lot of algebra. So if you're still writing this, go ahead and hit pause. I'm going to move to the next step and write out what I mean by partial fraction decomposition. So either recall or note as a new special thing that if I have 6 over s plus 3 plus 26 over s plus 3 times s squared plus 4, that's going to be the same as 6 over s plus 3, I'm fine with that one, plus I can break up that messy fraction into something over s plus 3 and something over s squared plus 4. And those are denominators that I know how to deal with. I've got my exponential and my sine cosine type. The way it breaks up is that I have a over s plus 3 and bs plus c over s squared plus 4. People often ask about how you know that this one has s on top and this one doesn't. I'm going to be trying to balance equations. So when I recombine these fractions, I multiply a by that and bs plus c by that. And so in order for a times s squared to have something to balance with, I need bs times s to give me bs squared. That's how I know that I need to go up to having an s in that term. And then once you know the higher, you add everything below it. There are other ways that people learn to remember this. And if you introduce a bunch of unnecessary variables, they should all go away, but it makes the algebra much more complicated, which makes it easier to make mistakes. So when we try to solve for A, B, and C, we're just going to have a quick aside where we do this very long partial fraction decomposition algebra problem in the middle of our differential equation problem. But basically what we've said here is that a times s squared plus 4 plus bs plus c times s plus 3, if I combine those fractions, they would be over s plus 3 times s squared plus 4. And that's the same as whatever I started with. So I'm going to basically ignore what's on the bottom. I set up the top so that this was a problem for the fraction that I'm decomposing based on what's on the bottom. And now all I'm going to do is make the top part of the equation equal. So I want to have that 26 is equal to a times s squared plus 4 plus bs plus c times s plus 3. Multiplying all that out, I'm going to be looking at as squared plus 4a plus bs squared plus 3bs plus cs plus 3c. It's a lot. And then in order to make this equal, I want it to be true for any value s, because I don't know what s is. It could take on any value there is. So in order to specify a, b, and c, I'm going to group like terms in s. So on the left side, what I've got is 26. I don't have anything to group, but I do have to note that I've got no s squared terms, no s terms, and then my constant type term, 1, is 26. And on the right side, my s squared terms are as squared, so I'll pull out an a, plus bs squared, so I'll pull out a b. Then my s type terms are going to be 3bs plus c. And pulling out the s, I'm just left with 3b plus c. And then my constant type terms are 4a plus 3c. And then I'm not sure how much longer this is going to take, so I'm going to go ahead and pause here now that we've set up these equations. And in the next video, we will continue this, try to make a system of equations we solve and get back to the solution that we want to have.